How does a neuron learn? In other words, how does a synapse change after experience so that a neuron is more likely to fire an action potential to the same experience in the future? I'll talk about one example, synaptic tagging. To orient you, I've shown a neuron here with the axon terminals at the end where neurotransmitter would be released to the target postsynaptic neuron, the axon with the spike initiating region where we need to get enough charge to start an action potential, the cell body with the nucleus where messenger RNA is being made, and then the dendrites with axon terminals from the incoming neurotransmitter and dendritic spines. All of these are places where there are synapses. I want to zoom in on one dendritic spine. The dendrite, one spine, and here's a synapse with neurotransmitter vesicles from the presynaptic neuron. And when those are released at an action potential, here's our neurotransmitter binding to a neurotransmitter receptor, and in this case, an ionotropic receptor, so that upon binding, the channel opens up and sodium enters. That sodium entry then is positive charge, which is repelling nearby positive charge in all directions. If enough positive charge reaches the spike initiating region, we get an action potential. Now that same sodium coming in could also open voltage-gated calcium channels. The positive charge repels the gate and calcium enters. The calcium entering can bind to a calcium binding protein, and there are multiple different calcium binding proteins, and different learning circuits use different ones. That calcium binding protein now has a change in shape because of the calcium, and with that change in shape, the calcium binding protein can bind to a kinase or phosphorylase, which can add or remove phosphates. Let's assume in this case it's a kinase, and so it adds PO4 - 2 to proteins, which of course will change their shape. And so here are a couple of proteins that are activated kinase phosphorylates. So we have now some proteins that have been activated, and in this changed shape, they can cause events to happen. Typical dendrites in neurons that can do learning have both messenger RNA 1, 2, and 3, I've shown here, that are for proteins such as neurotransmitter receptors and synapse proteins. If this messenger RNA can be expressed, then we'll get potentially more neurotransmitter receptors and other proteins in the synapse. We can make that synapse bigger with more neurotransmitter receptors. These proteins start the process of translation of these pre-made messenger RNAs. So in this case, we might have messenger RNA 1 going through. As it goes through the ribosome, we build a protein, and that protein might be a neurotransmitter receptor. Messenger RNA 2 might be for a different synapse protein. If the neurotransmitter receptor is then moved into the membrane, we now have new neurotransmitter receptors, new action potentials. Instead of having just these 2 neurotransmitter receptors to bind to, now have 3. In other words, we may have gone from a few hundreds to twice as many neurotransmitter receptors, and so the next action potential that happens will let in maybe twice as much sodium, causing 2 times the charge to move toward the axon hillock. This neuron, and specifically this dendrite, has learned by experience to respond more strongly to the next action potential.